Hi, I'm Matthew Mans. I'm the project manager for United Engineering. We're here to talk to you about the Crown Point Business Project. So the members of there we go. So the members of our team are Addie, the structural engineer, Morgan, our environmental, and Andrew, who is our transportation engineer. The first person talking to you will be Addie over Zoom about our transportation, or not transport, structural part of the project.
Yes, so today I'll be presenting the full semester progress update for the mixed-use building located at 1106 Marable Road in Crown Point, Indiana. It is 40,000 square feet, 2 stories, with a restaurant on the first floor and 14 residential apartments on the second floor. All structural decisions were based on ASCE 7-22, the ASCE hazard tool, ACI 318, as well as AISC. For the phase 1 cost estimation, I used RS means 2025. So we began the semester by looking at 3 different alternatives. This slide just gives a brief overview of the building materials chosen before I go into the floor plans in the following slides. So the first alternative is the all steel framing with W-shaped beams and columns with steel decking and a concrete slab. It uses a 25-foot grid, which allows for an open floor plan for that restaurant space below, and steel also allows for fast erection. The second alternative is the all reinforced concrete frame that uses reinforced concrete beams and slabs with a 20-foot grid. Concrete offers great fire resistance and sound resistance, but has slower construction time and an overall higher cost. The third alternative is the hybrid option, which uses steel beams with wood joists spaced at 18 inches on center, keeping that same 25-foot grid as the all steel frame. It's lightweight and offers a mix of materials. So for the all steel and hybrid options, I use that same 25-foot column grid in both directions as shown in that image. This span works well for that restaurant layout below and limits the number of columns while maintaining a cost-efficient design. So for the steel frame alternative, the second floor uses steel decking that spans about 10 feet, supported by steel joists spaced at 5 feet on center, creating that uniform load distribution across that 25-foot grid. This creates a composite floor system once that concrete topping is placed. It's lightweight, strong, and allows for very fast erection. So for the hybrid option, I kept the steel beams but used wood joists spaced at 18 inches on center. This provides a lighter floor system and avoids a costly steel deck by placing hardwood flooring directly over those wood joists. However, wood does introduce vibration concerns and it would need additional fireproofing. And with how closely spaced the joists are and with how large of a building this is, it ends up not being as cost effective as we had hoped. So for the concrete alternative, I used a 20-foot grid because of the heavier weight and the larger structural depths as lengths increase. The layout increases the number of columns and reduces that clear span that's needed for the restaurant space. So although concrete does offer great fire resistance and sound insulation, the not as great part is the added structural weight and overall higher cost. So to compare the 3 alternatives, I used the weighted decision matrix. Some of those key parameters are shown on the left. After assigning different weights, we were able to score each of those alternatives. So the steel framing option has a score of 83, concrete at 78, and that hybrid option at 43. So steel did score the highest overall due to its speed of erection, its overall performance, and the efficient long spans of that building for that restaurant space below. So that selected system will be moving forward into the spring semester. So finally, here is the cost summary using RS means 2025. In addition to that base building cost, I included several features for those 14 apartments above. These being 14 kitchenettes, that includes a stove, refrigerators, pretty much everything that you would need in that kitchen. A 2,500 pound capacity elevator, 4 washers and dryers, which is efficient for those 14 apartments, as well as 50 smoke detectors, which is about 2 to 3 smoke detectors per apartment, and extras for that restaurant space below. I do want to note that the estimate does not include contractor or architect fees, as that's going to vary per company that's going to build it. It only covers the main construction materials and systems. So overall, the steel framing is fast to build. It has great open spans for that restaurant space and is the most cost-effective building for this project.
Thank you, Eddie. My name is Andrew Webb. I'm the transportation engineer for the Crown Point Business Park project. So quickly, I want to recap our previous presentation. So we have a site layout here with 24 parcels, and we will be developing this 1.9 acre parcel here in the southeast part of the site. We have a new road that will be running through the site. It will be roughly 0.36 miles long, and it will have a 30-mile-per-hour design speed, and it will connect Middleville Road to Indiana Avenue. The cross-section of the road will be 60 feet total right-of-way width, with 31 feet from curb to curb, and there will be a green space between the curb and the sidewalk. The vertical design of our road is fairly flat with only a 5-foot elevation difference. The highest point is at the Middleville Road intersection, and we have 2 lower points midway through the road. So recently we conducted a cost estimate on this road using the INDOT 2024 unit price summaries adjusted for inflation, and we found that this road will cost just short of $800,000 to construct. The main costs are the asphalt pavement, the aggregate subbase, the curb and gutter, and the sidewalk. So next up is the parking lot. So the Crown Point zoning ordinance states that for our building, we need 149 parking spaces, 45 for the apartments, that's 2.5 spaces per apartment, and 104 spaces for the restaurant, and that value is based off of the 20,000 square feet for the restaurant. As you can see, the parking lot does not fit in the parcel, so we have decided for now to design some of the parking lot in parcel 20, the neighboring parcel, and when a building is developed in this parcel, it can share the parking lot provided that the use is compatible. And this parking lot design is still subject to change based on further building design that we come up with. Similarly to the road, we conducted a cost estimate for this parking lot, and it came out to about $412,000, so roughly half of the cost of the new road. Next up is the intersection redesign at Indiana Avenue and Summit Street. So this intersection is currently operating at a level of service C, with moderate delays averaging about 30 seconds per vehicle. And with additional traffic, we estimate that there will be 184 new trips from the parcel that we are developing during the PM peak hour. And if we extrapolate that to all 24 parcels, once the entire site is developed, that is over 4,000 new trips during that PM peak hour. We estimate that due to the fact that there are 4 main intersections around the site, about 25% of that traffic will be using this intersection, as all the intersections have similar current volumes. And we estimate that about 10% of that traffic will be coming from the east and 10% from the south, with 5% coming from the west. So we developed 3 alternatives for this intersection. This first alternative is the no-build option. This one has been eliminated as it is expected to operate at a level of service F with delays exceeding 3 minutes per vehicle, which does not meet the requirements of the project. The second alternative is adding additional lanes to this intersection. So we have right turn lanes added at 3 approaches, and then for the northbound approach, instead of a right turn lane, we have a second through lane to accommodate the additional traffic that will be heading northbound into the site. And then these 2 lanes headed northbound, the left lane will become a left turn only lane into our site. We conducted a cost estimate for this alternative, and this one is expected to cost around $1.4 million to construct. Alternative 3 is a 2-lane roundabout. This alternative will operate at a level of service C similar to the previous alternative. This alternative will have 2 lanes coming into the roundabout on all 4 approaches, and 2 lanes exiting at 3 out of the 4, with only 1 lane exiting southbound. That was due to space constraints with this building here, as well as the high demand for the left turn movements going this direction. So these additional lanes headed downstream of the intersection will have to merge to bring it down to 1 lane each direction. We conducted a cost estimate for this alternative and found this one is only slightly more expensive at around $1.5 million. So this is a cost summary of all 3 alternatives. So alternative 1 being the eliminated alternative at a cost of 0, which brings it to a total of $1.2 million, including the new road and the parking lot. And then alternatives 2 and 3 are very similar, around 2.6 or 2.7 million. So we used a decision matrix to evaluate these alternatives. Although alternative 1 has been previously eliminated, I left it in here just for a comparison. So we weighted each of the alternatives on 5 factors: the level of service, pedestrian accessibility, cost, ease of construction, and the right-of-way impacts. Each of those weighted according to the relative importance. And we assigned each one of those alternatives a scale from 0 to 5 in each of those categories. And alternative 2 came out with the highest score, receiving 80 points. And so this is the alternative that we have selected to continue our design with. And so shown here is a zoomed out version of the entire alternative. Note that northbound is to the right in this image just to fit it on the screen better. So as you can see, we have 2 lanes forming here, and then the left lane will become a turn lane only into our site. And with that, I would like to turn it over to our environmental engineer.
Hi, I'm Morgan. I am the environmental engineer for United Engineers. Today I will talk about 2 different sets of alternatives that I analyzed. The first one I did talk about on last part of the presentation, but I would like to go over it again and show my design matrix. So I chose, it is the lift station locations. Those were chosen at low points on the site, making sure to avoid the floodplain, and also just keeping in mind that it needs to connect into an existing sewer system. So the design matrix I have for this, the key parameters are the elevation, so making sure that it is a low point since this is a gravity collection system, as well as location to the road to be able to tie into the existing sewer system, as I mentioned, and then making sure that we are away from the floodplain, and then also access to the existing easement. This one is weighted only a 1 out of 5 because that is not as important because we can make a dedicated easement, but it would just be easier if we went ahead under the existing easement of the NIPSCO power lines. So as you can see here, the alternative 3, which was the location that was closest to Indiana Ave, is the one that scored the highest with 51 points out of 55 total, and that is the alternative that we will be moving forward with. The next is the pipe material alternatives. So I chose 3 pipe materials: PVC piping, ductile iron, and HDPE. And so PVC pipe, it's just a plastic pipe that's lightweight, flexible, and pretty durable. And ductile iron is an iron pipe. It is very strong, durable, and also flexible. And then HDPE, it is also a plastic pipe that is strong, resistant to corrosion, and durable as well. And so I conducted a design matrix as well for these, with the key parameters being durability, flexibility, strength, resistance, velocity range, to make sure that it can, our flow does not start to erode the pipes, as well as the pipe and installation cost, which I will show at the very end. And then if it is on the approved materials list, I would like to mention HDPE is not actually on the Crown Point technical standards on the approved list. I did include it just to have that third one and kind of compare it, compare it to PVC and ductile iron, although it has been eliminated from selection due to it not being approved. So as you can see, PVC received the highest with 95, with cost being the main factor of why it was chosen. Although we will not eliminate ductile iron because, as I will show on the next slide, ductile iron is stronger and will need to be used when we go underneath the road right here. There is no way we can lay this pipe without going underneath the road. We either have to go underneath the road here or here. So we cannot completely eliminate ductile iron, but PVC will be used for the majority of the pipe. I showed this pipeline routing. It is a little bit more finalized, I guess you can say. It's obviously not final as I don't have any of the elevations yet. But I have placed the tentative manhole locations at every bend, as you can see in the zoomed in photo right here. And then also if there is no connection more than 400 feet, manhole is placed there as well. And then I would also like to note that we are following in the right of way. As Andrew mentioned, we have 8 feet of green in between the edge of the curb and the sidewalk. So I do apologize, it's not very easy to see up here, but if you can see, the red is the pipe, the cyan is the edge of the road, and then that gray is the sidewalk. There are a couple locations where we do go underneath the sidewalk, but no manholes will be placed on the sidewalk so that any bikers, pedestrians, anyone using the sidewalk doesn't have to worry about falling and tripping over a manhole. And then so now I want to go over the cost summary. So to do this, I used the total length of the schematic pipe, and I assumed that the pipe diameter will be consistent throughout the whole pipeline, although that is more than likely not the case in the final design, as it is as I mentioned, it is gravity. So as the slope increases, the velocity will increase, and then we will need a larger pipe diameter. But just for convenience, I just showed 4 different diameters, and to do that I used the cost of the pipe as well as construction, which I got from RS Means, as well as the trenching and backfill cost. The trenching and backfill cost is the same for both PVC and ductile iron. As you can see here, PVC is significantly more cost effective than ductile iron, which is why it was our main choice, with only a section of the piping going to be ductile iron. And with that, I will pass it to our water resources.
Hi, so the requirements for the water quality scope of the project are, I have 2 major sections, is the flood control plan and the water quality plan. The flood control plan is over the entire site. It's minimizing the outflow to be less than 0.2 CFS. And when it's scaled up, it's around 10 CFS is the maximum outflow at any given time. And then for the water quality plan, I need to reduce the total suspended solids by 80% and the total metal load by 60%, as well as infiltrating 1 inch of runoff from impervious area on the site, or it could filter it out. So for the for the watershed diagram, this is a modified version from what I presented last time. There's more area that is treated by the detention ponds, which are to scale on this diagram, and it shows the location of the vegetation swales, which are in blue there, leading to where the detention ponds are. So for the scope of my project, we have a new parking lot design, which was vastly different from the previous estimate that I was given. So most of my work would have to be altered for the water quality plan. I need to treat pretty much double the impervious area runoff. And since we increased it to a second parcel, all the BMPs will also have to be moved. Mostly on parcel 20 is where most of the BMPs will be used to treat water before it leaves both of the parcels. On the screen, there's the water quality volume, which has gone from 3,600 to 7,800 100 cubic feet that needs to be infiltrated before it leaves the site. So here is my old alternatives. I didn't have enough time to update it for the new parking lot as the changes were made recently. So on here, it was using primarily rain gardens and an infiltration trench, which focuses on treating the water that's coming off from the parking lot and the building. And here's the cost estimate. It's around what alternative 2 is in terms of pricing. It's $3,000 more. However, much cheaper than alternative 3, and it treats the same amount of water as alternative 2 does. So alternative 2 also uses rain gardens. It also uses dry wells instead of infiltration trench, which can be considered an injection well, so it's not going to be used in any future things because we want to stay within compliance of the area. And then it has vegetation swales too. The filter strips would be placed in a different location. I didn't edit it on this graphic since it's not going to be used moving forward. And these were the old designs that I had. And the total cost is $40,000, similar to alternative 1, and has a lower footprint area used. Alternative 3 uses tree boxes. The numbers that I used for the square footage for the tree boxes are different than in this graphic because once again, they won't be used. But it treats a lot more water since in this design, the parking lot would be using permeable parking lot for the treating the water. So the cost is around double as the other things, but it uses a lot less square footage for extra, not including the parking lot or the building. And then here's the decision matrix. Alternative 1 is the best because it's consistently higher on the different criteria that I used to rate them. And alternative 2 is worse because it may not be compliant if the dry wells aren't designed properly. And then alternative 3 just costs a lot more. So moving forward, I will be using a modified version of alternative 1, which may include tree boxes in certain parts of the parking lot as they're good for treating area in the middle of parking lots. Since you can employ extra thinner green space, which is already built into the parking lot for our design. And then we'll be using the other BMPs used in alternative 1 along with filter strips for added filtration. And then future work that I'll be doing during the second semester is sizing the BMPs and changing the placements to reflect the new parking lot design. Is there any questions?
Okay, Matthew, so you decided to use sort of a modified or combined type of pest management practices. Did you do the calculations to see if they will meet the scope of the project in terms of the % removal of heavy metals and suspended solids?
So I did do the calculations for the total suspended solids. I didn't for the total metals because it was going to be well over the amount since I primarily was going to be employing infiltration for the alternative. But it was enough for the total suspended solids. I didn't think I would have enough time to include it in the presentation, so I did.
Andrew, because you showed that close up on Merivale Street in there, I did not see any acceleration deceleration lanes connecting Merivale Road with the new road in there. Do you plan to include those in this case?
So I did not. The speed limit on Railville Road is only 25, so I don't think acceleration and deceleration lanes would be as necessary. And also, the traffic on Railville Road was only about 4,000 vehicles per day, whereas Indiana and Summit Street had about 10,000. So I didn't think it was...
Let me change my terminology, call it an approach like lane in this case rather than acceleration, deceleration. I mean, if somebody's gonna make a right turn on Merrill Street, so the traffic behind that car got to stop, sort of.
So that wasn't part of the initial scope, but that is something I could take a look at in the future.
Okay. There. I mean, Morgan, I did not see anything about like the forced main. So you have a lift station
Yeah.
on that selected side.
The force
So-
main, oh, sorry.
Go ahead.
Oh, I was gonna say the force main will be at the same location as the lift station, but I haven't done any design. That is for next semester, so I didn't mention it.
No, I wanna know where it's going. So,
It'll-
yeah, it starts at the lift station.
Yeah, so it'll start at the lift station and then, can I have the little guy, or remote, sorry, not little guy. I don't know why it's not working. So if I go back to my pipe, if I can find it. The lift station will be here and then the force main will be along there to help it connect into the existing sewer system. You can't see it very well, but there is a blue line and that is where the, so we don't have the existing utilities map, but I did go through Google Maps and do like the street view, and I found the manholes already, and then I think there was one down here and then one up here, and I assumed they were just parallel with the road, and then that little dark blue line is where the existing sewer system is assumed to be. And then so the lift station will, or the force main, excuse me, will be in between the lift station and the force main, or the force main will be between the lift station and the existing, sorry.
Yeah, I guess, since I'm asking it. Did you use RISA to come up with the layout of those, building, of the building,
Sorry, I don't have access to RISA or CAD on my computer, so I used MBS, the Metal Building System software that I use for work, to model out these buildings.
Well, I am impressed, I'll tell you that, they look good.
Thank you. I had my boss review them and make sure that everything came out right.
Oh, that's part of the cheating thing, so I'm just saying, yeah, good. No, I'm kidding, yeah, so. I'm done.
We can use this diagram right here, where that road intersects, this is for Andrew, where that new road intersects with, was that Indiana Avenue?
Yes.
It's the same kind of offset intersection kind of thing. What is the distance from two existing roads coming from the west? Is there enough room in between those two to make that stuff work?
I can't remember what the distance was off the top of my head, but I can double check that. I believe it was enough distance, but I'll look into that more in the future.
Yeah, the other one, the team before was much closer and was not a good, so maybe it works in the middle.
I wanted to avoid having it too far to the north, because then we wouldn't be able to access.
And you certainly don't
some
want
of
to
the
change it now
parcels.
because the rest of your team will be very angry to have the alignment change.
Yeah.
But that's the way it works in the real world. Okay, that's all I have.
Is it a stop sign, or what do you have, what do you have at that intersection?
Yeah, there's a stop sign on the new road, and then Indiana Avenue is free-flowing.
Okay, it's a two-way stop sign.
Yeah, well, one way, because it's a
One way.
T intersection, but yes.
So I have a couple of questions. Matthew, you kind of answered my question when you answered Professor Algebre's question, but like, to get the 60% metal removal that you required, right? I think you're gonna have to address the part of the dissolved metals. So how much, and you said you're gonna do that through infiltration, right?
Yeah.
Is there any other way that you're doing that? And then do you have an idea of like what fraction of the water quality volume will be infiltrated?
For the water quality volume, all of that's infiltrated. There's extra water or stormwater that's on the site that isn't included in the water quality volume because that's just the equal to 1 inch of the, what do you call it? The 1 inch for every, just for the permeable area, not impermeable area for the site. And then there's a higher volume for the additional. And just mainly infiltration. I haven't done the calculations for the metal thing just because so I had previously not had done it already, and then since the parking lot was changed, I didn't go back to address the problem that I would have to
Okay.
change later anyway.
You previously had not done it.
Yeah, for the design or
Okay.
technical memo.
So I think most of the metals are probably coming off like the building and the parking lot.
Yeah,
So
which
that's-
in infiltration's gonna be like right there,
Okay,
so.
okay, thanks. And then, Andrew, you mentioned that your parking lot's bigger than originally
Yes.
thought, right? And you went on to the other lot and you're gonna, that parking lot's gonna be shared with another building?
Yes, that's the plan as of right now.
But the new building is gonna have more square footage and then require more parking, isn't it?
Yeah.
So won't the parking lot have to be bigger still and then,
Yeah, so it depends on what the use of that other building is. Like if it's an office building, the peak hour of the parking lot would be different for the office building
Okay.
and the restaurant, so they could share some parking.
okay,
And depending on the use, it might not require as large of a parking lot as a restaurant would.
do the regulations tell you how to estimate that?
They do.
Okay. Okay, thanks.
My comment, that's a bad recipe. Let the restaurant owner buy the other lot. And so they don't have to share parking lots. They can have all the space they want.
Yeah, my comment is that Addison needs to design a parking garage.
I definitely should.
Underground. Anything else? I got one general question for everybody. Why does the water resources person always go last?
Well, our group did it because we figured that transportation and structural were the most important two sections of the project. If you're a client,
True. Right.
The last thing people think about.
I feel like the environmental and the water resource person's just building something to get the actual main product.
Because you need it.
Yeah, you need it.
Okay.
We were choosing like going big.
Okay, thanks.